Have you ever wondered what makes materials such as the steel in this bridge so strong? Or have you ever thought about what makes materials like plastic melt when exposed to heat? Or glass shatter when something hits it? Perhaps you've observed that materials like wood and paper burn easily, whereas other materials, such as this steel poker, do not burn. What makes these materials behave the way they do? The answer lies in their chemical composition. More specifically, in the way their atoms are arranged and held together. During the next few minutes, we're going to explore some of the properties of atoms, and we're also going to discuss how atoms combine with each other in the process of chemical bonding. You compare. What makes the copper found in this wire different from the helium gas used to fill balloons? Copper is a metal which readily conducts electricity. It tends to be orange in color and is found in the wiring of your home and school. Helium gas is not a metal and does not conduct electricity easily. So, as you can see, these two substances have properties that are quite different from each other. These two substances are two different elements. An element is the simplest type of a pure substance that cannot be made any simpler by chemical means. In other words, it's a chemically pure substance. Gold and silver are other elements with which you may be familiar. There are over 100 different kinds of elements. Elements are made up of a single kind of tiny particle called an atom. Aluminum, found in this flashing, for example, is made up of aluminum atoms. An atom is the smallest part of an element that still has all of the properties of that element. Each different kind of element is made up of a different kind of atom. Let's take a closer look inside atoms. Our bodies are made up of millions of microscopic cells. Cells are the building blocks of life. You decide. What are the building blocks of cells? Atoms are the building blocks of cells. In fact, atoms are the building blocks of matter. All living things are made of atoms, as are non-living things, such as rocks, as well as objects we use every day. There are billions of atoms in this single drop of water. Believe it or not, atoms are made up of even smaller particles called subatomic particles. There are three different types of subatomic particles: protons, neutrons, and electrons. In the center of the atom is the nucleus, which is made up of protons and neutrons. This is a model of an atom of carbon. It has 6 protons, which have a plus sign, and 6 neutrons. Protons are subatomic particles that have a positive charge. Neutrons have a neutral charge. Over 99% of an atom's mass is located in the nucleus. Swirling around the nucleus are electrons, the third type of subatomic particle. Electrons have a negative charge and orbit the nucleus at extremely high speeds. You decide. What makes atoms in the element gold different from those in lead? The atoms in these two elements have different numbers of protons, neutrons, and electrons. Gold has 79 protons, 118 neutrons, and 79 electrons, whereas lead has 82 protons, 125 neutrons, and 82 electrons. Due to these differences in chemical structure, these substances are very different from each other. We already discussed some types of elements, such as silver, gold, copper, and lead. And we mentioned that there are over 100 known elements. But think about all the different substances found on Earth. There are thousands. Common examples include water, salt that we sprinkle on food, sugar that we cook with, and vinegar that we put on salad. These are all examples of chemical compounds. A chemical compound is made up of two or more elements that are chemically combined or bonded together. The combining of atoms to form a new substance is called chemical bonding. The way atoms bond together is determined by certain characteristics of their chemical makeup. Let's take a look at some of these characteristics. We already know that different kinds of atoms have different numbers of protons, neutrons, and electrons. Protons and neutrons are found in the nucleus. But how are the electrons arranged? The arrangement of electrons outside the nucleus affects how atoms bond with other atoms. Electrons are arranged in energy levels. Energy levels are kind of like paths around which electrons move. Each energy level can hold a certain number of electrons. The first energy level can hold only 2 electrons. The second energy level can hold up to 8 electrons. The third energy level can hold up to 18 electrons. Larger atoms have more than 3 energy levels. The electrons in the outermost energy level of an atom are called valence electrons. These valence electrons play a critical role in determining how atoms bond. Atoms tend to bond in ways that make their outermost energy levels complete with electrons. When this occurs, atoms achieve stability, which is their general tendency. When an atom has an equal number of positively charged protons and negatively charged electrons, it has a neutral charge. For example, iron, such as that found in these railroad cars, has 26 protons and 26 electrons, giving it an overall charge of 0. You compute. What's the overall charge of iron when it loses an electron? When iron loses a negatively charged electron, its overall charge becomes +1. When an atom gains an electron, its overall charge becomes -1. An ion is an atom that has lost or gained electrons. Ions are charged atoms. Ionic bonding involves the transfer of electrons between atoms. In ionic bonding, an atom gains electrons and the other atom loses electrons. These positively charged pieces of paper are attracted to this negatively charged comb. This is due to the fact that oppositely charged particles are attracted to each other. Similarly, oppositely charged ions are attracted to each other in an ionic bond. This sodium atom has 1 electron in its outermost energy level, and chlorine has 7 electrons in its outermost energy level. When sodium and chlorine bond together, the sodium atom donates its electrons to the chlorine atom, making its outermost energy level full, forming common table salt, which is called sodium chloride. Sodium is a positively charged ion, having lost an electron. and chlorine is a negatively charged ion, having gained an electron. The attraction between these oppositely charged ions is the basis for the ionic bond. Many ionic compounds form a regular repeating pattern called a crystal lattice. Salt crystals are made of a crystal lattice that forms a cubic shape. If you have a sweet tooth, you probably like foods such as ice cream, cookies, and cake. These foods are sweetened with a chemical compound called sugar. Sugar is held together with another type of bond called a covalent bond. In a covalent bond, electrons are shared between different atoms. Atoms in covalent bonds are held together by an attractive force between the positively charged nucleus and the shared electrons. The bonding of two hydrogen atoms is an example of a simple covalent bond. Each hydrogen atom has a single electron. When they bond, they share the electrons and fill their only outer energy level with 2 electrons. Hydrogen can also form a covalent bond with chlorine, which has 7 electrons in its outermost energy level. When they bond, both of their outermost energy levels become complete. Water, one of the most common substances on Earth, consists of a covalent bond formed between 2 hydrogen atoms and 1 oxygen atom. You compare. What do this steel, the filament in this light bulb, and this can have in common? That's right, they're all made of metal. Metals are extremely important, used in building materials, and in common everyday objects, such as paper clips and staples. Most metals, such as copper, consist of atoms held together by metallic bonds. In metallic bonds, positively charged ions are surrounded by a sea of electrons, which are attracted to multiple nuclei at the same time. In a metallic bond, the outer electrons of metal atoms tend to be quite mobile. This ability of electrons to flow freely makes electrons good conductors of electricity, allows metals to be malleable, permits many metals to be drawn into wires, and accounts for the high melting points of many metals. During the past few minutes, we've explored some of the fascinating ways atoms combine in the process of bonding. We discussed how the structure of atoms affect how they bond with other atoms. More specifically, we explored how electrons in atoms, particularly those in the outermost energy level, determine how atoms bond. We explored the nature of ions and ionic bonding, which involves the transfer of electrons between atoms. We also investigated some of the characteristics of covalent bonding, in which electrons are shared between bonded atoms. Finally, we discussed metallic bonds and some of the common characteristics of metals. So, the next time you use a fork, measure out a spoonful of sugar, or sprinkle some salt on your food, think about the ways atoms are bonded in different substances. You might just look at the matter in your world a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. N is the simplest type of a pure substance. Number 2. The smallest part of an element is an Number 3. The combining of atoms to form new substances is called chemical. Number 4. Electrons in the outermost energy level are called electrons. Number 5. An is an atom that has lost or gained electrons. Number 6. Bonds involve the transfer of electrons between atoms. Number 7. Table salt consists of a lattice. Number 8. In a bond, electrons are shared between atoms. Number 9. In metallic bonds, the outermost electrons are quite And number 10. Metals tend to be good of electricity.